ये कमांड की हिस्ट्री आ गई है, इसकी कमांड मैंने बात ये बताई आपको, हिस्ट्री में सारा आ गया ये जो कमांड है।
Okay, I hope it is audible now. Okay, let's begin our decorating the new house. We are just moving to the new house, that is the deep. Okay, how we did that? We first install mini contact, we create an environment, and we moved onto that environment. By contact activate and the name of the environment, that is the deep. Okay. So now let me show you what to install first in this environment and how to install using Conda environment. Okay. There are two options in Conda installation. Let me go back to the old file here. One is the command called p install, and there is equally that is command called Conda install, and the name of the package that you want to install. Okay. One is pip install, another is Conda install, and after that you will be writing name of your package such as Jupyter notebook, Jupyter lab, and here also you can get that. You will be choosing one of it, okay, not both, but one of it according to your preference. In some cases, some packages are available under the Conda environment and some are available under the pip environment. Okay. So we are compelled to choose only one in some cases, but in many cases they are available on both. It is up to the developer where they want to store their code. Generally, most of the developers store their code on the both environment for the better visibility and wider reach. But some will prefer to choose on only one. Okay, in that case, you have to choose either pip or Conda. There is no other option to us. In pip and using Conda, it is our preference because the Python notebook is available on both. Okay, let us try this one. Pip install the Python notebook and you will be pasting this right into this terminal, but make sure you are on the deep environment. Okay, that will always remind you where you are, on which environment you are using. Right now we are using only one environment, so there is no other choice. We are always on the deep, but we may not be on the deep. Let me show you how to get out of this environment. Now you are out of the deep environment. Okay. Conda deactivate means you are out of, and if you want to go back to the deep environment, again do the Conda activate and you are back to the deep environment. This is how we will switch back and forth between the environments as well. If we have multiple environments and you want to get out of that environment and go to the another environment. Okay? This is roaming around the house in a big complex. You have to get out of that house and go to the next door, get out of that house, go to the next door. This is how we will do. Okay, now while I am on the deep environment, my plan was to install the divider lab. Okay, and make sure you do not mistake on the spelling, otherwise it will be error. And it will, and internet is necessary for this. Download all the dependency itself if you don't need to worry on the dependency. We will check, okay, what dependency it has been downloaded console right now. And this might take depend upon your speed of the connection. If the connection is slow, installation might take little while, but if it is fast, then it doesn't take much time. So this is how it happens. So once you look this area, the packages and just the name of package, but if you look on the sound, these are full versions. These many packages were installed now. Why you install the Python notebook? The Python lab. Okay. So but you should not worry. The Python lab will take care of this independently itself. So it is very easy. Just you have process. And these many packages are installed. Okay. Now be ready for the first assignment of our deep learning. Okay. And I will start with the example of physics for today. And later on we will explore other example also. We will do not limit on physics only. We will do on engineering, mostly civil engineering and other examples, even um, chemistry. Okay. Okay. Give me one moment. Okay.
Recording in progress.
Okay. Now, once you have Jupyter app, you are mostly able to drive. It is like a car. If you have a car, you can go anywhere. You can go Simla, you can go Chandigarh, Patinga, anywhere you want. Wherever you want, you can go. Jupyter app is a car of the deep learning or bike of the deep learning. Okay, now I install the Jupyter lab and like earlier, I will come to you, okay? Let me first demonstrate you how it works, and then I will come back, or volunteer will also come back to you and everything. Don't worry. Now the command to launch Jupyter lab is Jupyter minus lab. Okay. So, and hit the enter. Now it will show you another. Yes. So you have done like this. Right now you don't have the code, I haven't shared, but I will share in a moment. What you are doing is in the same set I will out in document. So my deep learning source codes are in my document and then DRI 2022 and component and physics. So here are some codes in the text panel. Okay. And on the right, let me show you what is as well. In the Jupyter lab, you will be seeing this screen, okay? Do not worry, your screen will be different because you don't have the code right now. So at least you have two screens, and this will be very similar to exactly like I have here. But on the left panel, your case will be different because you don't have this size right now. Okay? And the purpose is now I will do some small demo and I will give you some idea of code flow as well. And then possibly after the session, IT, obviously I have IT, and we will do a real hand and mind session. Okay, hand and mind session. Let me start with the very simplest problem of deep learning example 1. Anyway, it is not stop working, but let me open it. So it is a tested example. I also checked in the morning. Now I will tell you the big picture. Okay. If you jump to the fine details, you might lost right away. So let us understand the big picture and then go to fine details. That is our next agenda. The big picture is like this. At the very beginning, we will be calling all the libraries. Libraries are yesterday all earlier sir told that it is written by experts or groups of experts worldwide in a like-minded people, and they are well tested, well maintained, and there is no compromise on accuracy, reliability, and performance. Okay, we have to everything: accuracy of our source code, reliability, and performance as well. So these are the few source code. Right now I haven't installed in my code environment, but I will show you how to install it one by one. First of all, I am calling here methodology because all there is to have joined on Zoom. Uh, okay, so it is visible from the back. Okay, good. First method is I have in call, and then Panda. Okay, Panda is a library to manipulate the data frame or create data frame and non-5 numerical Python array and TensorFlow. That is the most important thing we will be doing today. And another is TensorFlow and ERK log, scikit-learn, that is another library for doing calculations and splitting the data set into two different sets. So these are called libraries. What we have to do is first we call the library that are required for our recording. And next is read your data frame. That is what we have to KYD. KYD, know your data frame. So in the second cell, I am reading the data frame like here, for example, it is the example of perovskite. So inside the data folder, there is cero.csv file as well, where I have stored all the lattice parameters, including its ionic radii, van der Waals radii, and oxidation states of like 100 perovskite crystals, which are non-cubic but in tetrahedral state. And I am just checking whether I read correctly or not. So I am displaying the results right now of some of the perovskites. And after reading the file, the data file, what I want to do is I want to know the more information. That was just what is in the file. Now I want to know more about that. Means I want to know columns and their characters of the columns. So that symbol number is there. The first column is symbol number, and which is integer 64. The data type, it is called data type in fact. And compound, it is the object, means it is the string or character. And RA, radius, ionic radius of element type A, ionic radius of element type B. Oxygen is not required, okay? Because oxygen is in all the compounds, so I can drop oxygen from here. And ionic radius, and valence state. There means valence state of that compound A and overall of that element. The equivalent location and ABC. ABC are the lattice parameters, and alpha, beta, gamma is not required here because they all are scientific. Okay. So these are, and the size of file is around 8 kilobytes. So this will be, we are going more deep inside the character of our data. And after knowing that, I want to know other type of information. Features, that is what I have told you yesterday, showing you the example of the Titanic. I have to get that also. What I am doing is, I want to divide that data into two parts. One is the target, that is what I want to predict later on, and next is the feature I want to include them while predicting the target. Okay? So data frame is divided into two distinct categories. One is called target, that is I want to predict later on, and first is the and other is the feature that controls the target. Okay, feature controls the target. And here I am reading that way. This is the feature. In the feature, I have different radius and balance state. Okay, I have jumped on those variables as a feature, and my targets are the parameter of the lattice function, which is along the length along the y-axis of the feature. Okay, and I am dividing that data frame into this kind of two things. Do not worry right now. I am not doing anything here, not even calculating this thing. And normalization. Next part is, although it is optional, normalization part, but highly recommended. Okay, optional but highly recommended. What does that mean? Suppose I might tell this. Let me show you two examples. One is a screwdriver, and another is a battery, manual battery. Okay, this is around 5 centimeter in length or 4 centimeter, let's say roughly. This is 26 centimeter in length. The difference is 15 centimeters. Okay, or 20, difference is 15 centimeters. So if I tell the difference is 15 centimeters, just that information. I do not tell, even I do not show this, I do not show this. I am hiding this. And I will tell that I have two objects of difference in length is 15 centimeters. That means I am misleading. If I do not show this object, and if I do not show this object, and what I will say only the difference in length is 15 centimeters. That is total misleading information. But instead, what I will show you, I will tell you that I have two objects of length ratio 1/3 or 1/4, let's say. That is more meaningful information. If I say that way, then object might get, the person who listens to this information will get that if he has 20 centimeter screwdriver and his other object is how much? 5 centimeter. That's very easy. You can get this, we know the ratio of length. That is more informative than the difference. Okay? So you have to normalize your data. That means you are expressing the information in terms of ratio or in terms of the maximum value. Okay, that way it is easy for everyone to understand in a meaningful way. So it is the best idea. Otherwise, it is misleading. Misleading information is very dangerous. Like you have heard Mahabharata already. Yudhishthir actually did not announce the wrong word, but he announced the misleading way about the death of Ashwatthama. Have you heard that story? That is a misleading information. That although he told the truth, you see how it works. Therefore, representation makes sense. Same wording, but he announced first word very lightly, but the remaining word he announced very loudly. But that was the presentation. So if I take the difference of these two objects, that is misinterpretation or misleading. If I take the ratio, that is more meaningful. Okay, so that's what I want to convey you. This is very important part of our machine learning. And now this is the normalization part in cell 5, and let's go to the cell 6. Yeah. Okay. Now it is the sales sheet. Okay. What is here is on the left side you can see four variables on the or four vectors. Let's say the vectors are X trend, X valid, Y trend, Y valid. Okay. These are the four vectors. What I am trying to do here is out of that figure, I want to divide that into at least one figure is divided into two parts. Like suppose I have 100 data. Out of that data, the ratio is 20. So 20% of data is reserved to test my model, to test the prediction, or 80% data is used to run the for the machine learning, used for learning purpose, and 20% is used for examination, whether I learn correctly or not. Okay. And similarly, all other variables are divided by 80-20 ratio. Okay, this is called splitting. And it is like this. We all are either teachers or students here. Suppose you have 10 chapters in your book, then what I will do is read 8 chapters thoroughly and try to answer the unread chapter, chapters 9th and 10th chapter. So that is result for our examination. Or you can read whole book like 100%, but your question is unseen question, not what you read, but in a different language. It could be a different language. But it is from the book context of the book, but slightly different, then that will examine your learning. So it is always required. Otherwise, you don't know how much you learn. If no exam, nobody knows how you learn. If you learn better, you will be promoted to next class. If you did not learn well, maybe you will be on the same class or next year or next semester, or you will be put on the previous semester as well in our very worst case scenario, according to your learning. Okay? So that is called reinforcement learning. In one type of deep learning, we call reinforcement learning. Although I do not cover that part, but I want to get you aware of it. Suppose you do very great, you will be rewarded. If you did not learn very well, you will be treated differently. But if your learning is bad, then you will be punished at that time. Okay? Although I do not do that part, reinforcement learning is not cannot be covered in 1 day or 2 day session because we are just starting the topic. And now I will build the model. Okay, after I split my vectors, I will build a learning model. It is like how you study in your exam time. How you study in your exam time is a model, learning model. And we do the same thing here. Such as I have, let's say, I have 32 books, not 100. So let's do like this because we are doing in a powerful computer. I have 4,096 books to study or pages to study. Books are too much. 4,096 pages I have to complete. Then how I will study is I will study 32 pages in one sitting. 32 pages. That is called that size. Okay. And I have a activation function ReLU that I showed you yesterday in the last class. Okay. And input save is high means I have 5 chapters on that 32 page here. This is how the learning model I am planning. Starting plan. And later on, I don't need the set because it is controlled by the number of neurons. Okay. And these are by the way neurons. And this layer is the I have comment also here. Input layer and hidden layer. Then after I finish that study, then I will discuss with my friends one time. That is a part of hidden layer. because here only 1 million there, and I will go to exam. Okay, it is same like our study. It is not different because how we cannot do any better than what we learn. Obviously, what we learn is how we are doing until now is what we learn, and what we want to create is no better than what we learn. And this is the model, learning model, and we have to combine obviously this thing. Once you build the model strategy, that is a learning strategy, and you have to implement that strategy and you have to go into action. You really started learning is here in this cell number 9. Okay? And what happened, I will show you. This is very interesting. What happened, why I started taking, let me make like this. Or I want to change this branch. This is here. Oh, yeah, very good. Now, I can increase the font size. Yes. Okay. It is all visible on the one screen. Yes. I finished 32 pages. That is the meaning of equals 1. Okay, because in one equals and value is 32. Out of 100 times, sorry, I have to show this part as well. I want to start learning, and one of my purpose is X train, Y train, that is the corresponding vector. Y train is the target, X train is the feature. Okay, that is the feature vector is under the X train, and target vector, that is the only one vector because that is the lattice constant V in according to our classification. And I want to validate over the F valid means figure vector and target vector that I have divided into 80-20 ratio. Okay. And how I will do? My batch size is 32, my keyboards are 100 means on that strategy I want to study that 4098 or 100 times. 100 times. And my velocity is 1. What is that velocity mean? Anyone know exact meaning in Hindi of the velocity? Velocity. Velocity means how vocal you are. Means suppose you do something very silently without sharing any of your friends. That means, but you have done great job anyway. You have done very good thing and more impactful to the society, but you did not tell anyone what you did. Velocity is 0. Okay. Let's get back to the box of velocity of the program. Previously, we had press meet also around the box. Maybe you have seen on the YouTube video of Himachal Kavarnama. So, it is some sort of velocity 1, not 0, because we announced on the society what we are going to do. And in the inauguration session also, journalists came and take interviews of our principal madam, PK and myself as well. So we have again tell the society that, oh, okay, now we are conducting this program from today, yesterday. Okay, that kind of strategy is velocity 1. If we like announce this program in a Yahoo radio, television, or more news magazines or national. Okay. If we give this information on BBC, CNN, Friday Valley, White of America, and or New York Times, then velocity will be 4, 5, very well. Okay. That is called velocity. Means how vocal you are about your work. Now I am moderately vocal. That I will announce at the same time, once I finish my reading, I will talk that, oh, I love this thing, I will tell one time of velocity 1 level. So once that includes is this thing. Out of 100, why there are 2 lots obviously. While learning and questions are from the same questions what I learned. not able to perform better than 7.3%. This is my loss. That is around 7% I could not manage out of 100%. And there are other set of questions also we have not I learned at the time of learning. That is from the 20% set. Okay, because there was classification 80-20 ratio. Out of 80%, I did not very well, more than how much it is. 93% was my score for the first time reading, because that is the first reading answer is here. And 72% is from the on-scene question. So my learning is actually better. Even in first time I read that 4096 pages. And in the second case, when let's say third case, what happened is, it took me around 42 milliseconds to read that 4098 page, because I am computer, not a human right now. And I did better gradually. Before it was 7.3, it is a loss, okay? When the number is small, it is considered better. Now 74. Only 7.1% I could not do well. And out of the 20%, 7.09% I could not do well. So loss in reading and loss in unseen questions is more or less required. That is very good learning actually. Very good learning. Let's keep on going all the way down at the last stage. Because my plan was to study that 496 pages for 100 times. Okay, that is the meaning of equals. Yeah. While I was reading for the first time, my performance, my figure was 7.3%. Now it is 3.9%. I did twice better at least in the figure. And similarly on the on-scene question part. So this is how I learned over the 100 times. Okay, over the 100 times when I began learning those 4096 is 100 times. My learning was good at the last stage that I am ready for the exam. Also, I was ready for the first stage also, because 93% is not that is over distinction. 75 is the distinction. So I was in the first reading and I am a distinction. I got distinction. That was very good learning, just by one time reading. So I am reading that, keep on reading for 100 times those pages, and finally I also increased my accuracy of learning, but not very well over the reading. Yes, this is because of the random seed I had chosen. Okay? And sometimes what might happen is it is possible on the computer, and all our tasks will also grab the part of CPU like browse over the time. But that is not part. Main thing is this box is our main concern. How we learn over the time. Basically, even after reading 100 times, my reading was actually not better. Reading economy, let's say like this. Reading economy is not good. Because while I reading first time, I was distinction. I was getting distinction. Even after 100 times reading, I am only increasing 4%. I am improving only 4% after 100 times reading. Is that a good economy of reading? I don't think that is, because I spend so much time, 100 times reading of that 4096 pages, and my score increased by only 4%. That means I do not spend that much time. At least I have no patience of doing that. Maybe you have, but I don't have that patience. Because in the first reading I got extension of book. So who cares about that? After that, who reads that book? I will go hiking or biking, swimming, and any other fun work. Because I got extension while I read first time. So no need to spend time on further reading, okay? But if you are really genius, you will do this work. really genius person will do this work. Okay. Yeah.
Data normalization work in that or not?
Pardon?
Data normalization work in that or not?
It is working. Yes, data normalization already performed.
Because the first time that was 7 point something, but on the question point output was 9 point something. Finally, it comes to 3 point something, and on the other hand, it is also so the given rate is better than 100 times.
Yes. Actually, it is again misleading to that. That's why I want to tell. The thing is slightly misleading here. So overall big picture here. I will show you the big picture, and then you decide whether it is wrong or right. I do not tell actually that. Even I have no basis to tell whether I did good or not. It is the personal preference that you did good or bad. But anyway, the clear information is that after reading 100 times, you increase only 4% of mark. That is the true thing. Okay? And it is a personal preference whether you like to read 100 times that 4,000 page, 4,000 almost 100 page, and improve your only 4 marks out of 100 marks. Okay? But reality is that even after reading one time, you are over the decision. Okay? You are over the decision even after reading for the first time. That's what the reality is. And it is also our personal preference whether you want even 1,000 times to improve and get a few more marks. Now, it is like a choosing a lemon. Let me give you very नींबू निकलना है तो एक मशीन होता है उसमें अल्युमिनियम का होता है भी होता है वो एक बार निकलो ज्यादातर रस तो उसी में आ जाएगा है ना और फिर उसको दूसरी बार निकालने से निकाल तो सकते हैं ज्यादा नहीं आएगा जैसे कि इधर रोड में भी मिलता है वो बनेगा जूस निकालते हैं मशीन में जाके और जैसा कि एक बार में पहली बार में आता है ना और उसको फिर दोबारा दोबारा कर सकते हैं हम लेकिन उसमें दूध ज्यादा नहीं मिलेगा एग्जैक्टली वही हो रहा है अभी आपको क्लियर फर्स्ट स्टेप टू around 30 times trading improvement is very good it is seen on the graph because it is directly falling down here is falling down from around 30 volts your improvement is not good after 30 volts let's go back to that data and see what is 30 volts yes let's see from here I think I have to put it there. Yes. Around here, the decrease is very steep. The decrease is very steep and it is stopped around 3.9%. Okay. So after that, it is also a significant improvement is really so it is like a sequencing those sugar can many times, 100 times, but you will get very little juice after that many. In principle, you can sequence that 1,000 times or 1 million times, but the product is very less. So we will discard that after 3-4 rounds. Then we will discard. Okay, here is the step. This is the big picture of our deep learning, and I have showed you the learning rate also. How was the learning improvement? And this kind of strategy is very plain strategy, extremely plain and novice strategy. That how machine learn. But there are many things to improve. And first is the best normalization and dropout. That is the one first improvement on this strategy. What is that is, suppose you are reading those books 42 times in one sitting, and you will be very monotonous and your brain may not work or second reading. You are not ready for second reading. So what is better to do is you stand up from that chair, go on your garden and come back and again start it. That is a good reading strategy we are going to, and next to the same thing. I will show you evidence here in the next slide. Let me open that next thing and how it is implemented. At least I will show that next part. All others are same except this part, except the model. Learning strategy has been changed now, and it is obviously better than earlier. What I am doing is I am reading 64 page at once. That is my I also increase the back side 64 pages for and other side answer. My studying pages are chapters are 5 and I am activation function is ready to answer. And I have more hidden layers here, like first hidden layer, second hidden layer, third, fourth, fifth hidden layer. I have 5 hidden layers. Means once I start learning, I will stand up from my chair 20%, and then I will do gas normalization. Gas normalization is however little distributed over the machine learning community, okay? But it is improving the result anyhow. It is the highly distributed algorithm, but the results are improved in many cases. And so I will discuss here, I will discuss with my friends what I learned, and then I will take rest, I will discuss with my parents, I will discuss my sister and brothers, and I will discuss with my teachers, grandparents, and then I will go to next reading. Next, I will come back to my chair and start reading again. After that, analysis. So these are the meaning of hidden layer, like this. And drop out is you take a break for a while, certain break. Like we are also doing here. And going to drink tea is a dropout of this class. And you might have done in college time also, that kind of dropping out. So when you went to college and suppose you will go to cinema or you must get park garden wherever you went, that's the dropout. But that will not harm your study. That is the evidence says, okay, not me, evidence says. And I'm not encouraging you to drop, however, but the evidence says that kind of thing. So this is one kind of improvement in the learning. We have enough time to practice, okay? So I will not run anything. Other standard as the Now let me go to the third improvement of the deep learning. How sometimes that kind of mechanism also doesn't work better. And this is the possibly undisputed only better algorithm I have in my model. And that is kind of industry standard answer. That is called only stuffing on the seventh cell of this. So this is the new addition to our machine learning strategy. What it does is, I will define my learning goal before I start starting my books. Okay? And that is the best strategy of learning. Suppose, let's say, if my learning rate do not improve by 1% of the subsequent reading, then I will not read further. That is first strategy. Although the list might be bigger, but as a pedagogical approach, I am only including two conditions here. There might be more. What learning rate is minimum delta means learning rate. Suppose either in first part is 0.7 and either in second part is 0.6, then that is good learning. So I will continue learning. I will go next reading in the hope that I will be 0.5 in next reading. Okay, if that is like 0.7 and 0.65, then I will stop. Sorry, 0.01 means 51 is smaller. Like 0.07 was previous and 0.06 was later, then I will move the next reading. If error is bigger than that, then I have to stop reading. Okay, error is bigger than that. Means at least 1% I have to be improve on every reading. Then I will continue my reading. That is my first strategy. And the second one is patience. Patience is exactly what we do in our real life. That means at least I will study 100 times. Whatever happens, whether I will learn or I will not learn better, but I will study that book 100 times. That is the second. So with these two strategies, I began to read my 4096 page now. And if any of these conditions fail, I will quit. Okay. So it has better. And what I will do is at last, if that is the case, and my plan is this, my father instructed or mother instructed to do this. This is imposed. This is imposed on me. That was my strategy, and my parents told me according to this. What they told me is that okay, read 32 page at once, and you have to read that book 1,000 times. That all parents say that 1,000 times. But I have set my criteria already. What is my criteria? If I do not improve more than 1% on subsequent reading, and at least, okay, I agree with you, at least I will read first 100 times. That is how I want to persuade my parents. Shopping criteria. And it is very unwise. So obviously on economics, definitely reading 1,000 times the same book without improvement is just wasted of time, money, energy, resource, everything. And yet, most importantly, we like old 63 years old or 73 years people with that many books at that time. So this is the exchanges I made. Okay. So basically we cover only these three things. First we will do plain deep learning, and then we implement dropout and gap normalization, and then we will do only starting criteria with the biggest what is called hypothesis. That means 1,000 equals. And I will show you the result what happened if that was the case. Yes, this is the case. So validation loss means actual performance on the exam, and this blue loss is the rehearsal, loss in the time of rehearsal. You are not performing directly on the stage, you are actually performing on your own with your own small group of artists. Okay. So from here around it will be around 58, let's say roughly. After 58, suppose your performance is not very good. However, and from here your loss is better. Validation loss begin later, and from at this stage the loss is around. I'm disconnected on the Zoom, but I can find it. Recording in progress. Let me see what they over there. Okay. Now, and because my plan was to study at least 1,000 times, because my parents tell me to read 1,000 times, so I was agreed to 100 times at least. Okay, I will read at least 100 times and let's see what happens. That is what I told my parents. And here I missed my criteria because the error is more than 0.1%, more than 1%, because it is, I actually lose my patience here. Although my patience was good because I studied 100 times, and when I began to study 100 times, around 150 times, then what happened is I began forgetting what I learned. I began forgetting what I learned because my brain is not working now. So I had to stop from here. Although my parents told me to go up to that road because 1,000 might be up to that road. But that was, I realized it is total uneconomic way. So I had to leave learning physics, or I had to go to chemistry, or I had to go to political science, economics, or finance. That was the learning strategy there. And also established criteria in our everyday learning also very important. Because without checking that criteria, it might be just total waste later on. Okay. So in the same way we do have only starting criteria is actually you have to learn all three. First go to plain learning with a minimum 100 equals if you can afford, and then go to background and normalization and see this how the learning was working. And then finally, because you have already had some idea how much you have to go, because right now, before I was going 200, sorry, 100, so learning was actually better here. Let me show you the final result of all these three learning. Okay, that I think. Wow. When I set the learning criteria and my parents are telling me to read 1,000 times, at least I improve my learning. My loss is just 2.8%. But before I was not doing that, even if, let's say from the beginning, how was it? 3.9% was my year initially, okay, without any learning strategy, any dropout, any bad normalization. And in second case, I had some little bit better model, including back normalization and other things. Although it is giving error, more error, in fact, 3.9%, which is more than the earlier error. And this happens because of the finite number of samples, okay? Because my data is on this error patch research only 100. So actually, it is slightly biased, it will be slightly biased. That's the reason. Otherwise, if your sample is bigger, then you will get better results. And tomorrow we will work on that. And I have a although it is freely available on website, there is an example of alcohol. Although I do not promote it, the alcohol test of alcohol is performed by 10 independent volunteers, and that is averaged out. They score the test of alcohol. How present is that stick of alcohol by a group of 10 volunteers independently they scored out of 10, and that was average, and that is our target. How pleasant taste is that alcohol, okay? Anyway, I am not promoting here alcohol again or let me disclaimer for this area. And alcohol has different chemical components, like it has pH values, it has sugar content, water content, and then actual amount of alcohol is added very few amount, possibly preservative, okay? So that will all enhance or re-enhance the taste of alcohol. Okay. So that there is no formula. Again, I told you yesterday about the complete block. Now I am telling about taste of alcohol. There is no formula that if you put like 5% sugar and then your alcohol will be tasting good. There is no association. Or if you put 10% water, or if you 10% like salt, or let's say 1%, 10 is too much. 0.1% salt and your alcohol taste good. There is no such formula. But you can learn and develop a model by the data, and I will show you that all the file I have right now to show you. It is that the CSV file I have, I can show you that. So this is how, and at least on the last stage there is a remarkable improvement. And one is the cost of this improvement is we are going higher reports. Beyond 100, at least we were tested before by 100. So now at least we know that how after going how much reports my learning is good is better defined now. Although my parents was enforcing me to go 1,000 times reading, but that was not my idea. So I am little better than my parents at least now. All you all are better than your parents in terms of knowledge. Also, they might enforce you to learn better because they love you a lot. And but you are more smarter, okay? And I am smarter, so I made a criteria. Otherwise I will be just one dangerously in these all. So overall big picture of the deep learning is this, and we will have some after this immediately. We will be, although we if time permits, we will work directly on this, but I want you to do not directly count on this one because we don't know how to, we haven't practiced how to manipulate our data sets. We don't know how to create an array or NumPy or how to visualize your data. Okay, so let us try to not to jump quickly on this one, but go in a more making our arm and leg more stronger. Then we can go to the real zone one zone. Okay, this is our one zone. So our sir told me to take a break now, and then we will continue. I like Monica, your question. Yes, the concept is like this. Suppose in the right example like here, if you are if here we are predicting the p value right from the initial, why do you predict the value of your new parallel line